Good afternoon, everyone. In the today's class of machine tools and machine cutting, we'd like to start with the unit number 4, that is a milling machine working process. Till now, we have a detailed discussion regarding the different types of machining processes and the internal parameters which are being involved with respect to the working sector and how many types of working units are being existed, how many types of guideways are existing for commencing the activities, etc. We have a detailed look in the case of this working process. And coming to the design characteristics, finishing structures, and particularly pointal mode of actions and the types of machineries that are having related to that, different working processes such as the mill drilling process, lathe machine working process, different types of lathes, different types of working processes in the case of this lathe machines, types of operating conditions, cutting parameters utilized in the case of this lathe machine. We had a detailed discussion. And regarding the drilling machine and boring machine, we had a detailed look towards it, the working and the types of machineries that are being existing. And for the heavy dimensional objects, what are the parameters need to be identified? And for the mini dimensional statistics of objects, what are the measures to be considered for working? We had a detailed chat out. In the previous classes, the shaper machine for transforming the irregular shape of objects to an normal type of machine, normal type of, the dimensions as per the vendor requirements. Planar machinery and slaughter machineries. So as per the required cut-off slots or dovetail rent of joints to be performed in different kinds of objects and types of working parameters, and it's progressing that we have seen till in the unit number 3 classwork. In the present day's class, that is the milling machine working process, as it is related to unit number 4 in your syllabus point of view, as displaying in the screen. In the milling machine, the basic introductory concept that why these milling machines will be utilized, what is the major principle of working related to these milling machines, what are the certain specifications need to be considered in the case of this milling machine working process, different types of methods that are being utilized, classifications related to the milling machine, operating features in the case of this horizontal mode of working milling machine, vertical case of this milling machine, and universal milling machine, depending upon different types of materials need to be performed over this milling machine. What are the types of cutters need to be indicated? What are the different geometric specifications of this milling cutters, methods of indexing, some of the accessories that are utilized in the milling machines for safeguarding aspect, or else for else for getting the particular dimensions which are in need of getting the precise in ratios in the working phenomena. Confiding of this cutting parameters such as speed, feed, and depth of cut, and calculating of this machining times or timing zones, we'll be discussing in detail in the milling machines concept. In this today's class, we'll be progressing with respect to one of the topic. There is a basic introductionary of this milling machine, and then the principles of this milling machine. And types of milling machine we'll be seeing in another one more class, and milling machine operation we'll be seeing in another class, and its applications and what kind of applications in the industrial sector, that in a minimal aging conditions and maximum working units, its advantages and limitations will be looking in a detail. Normally, this is the milling machine, which is having the capability of machining over the surface of the objects which are in a fixed condition. This is the tool. Normally, we'll be utilizing this steel tubes or CBN tools, carbon boron nitride tools, also the PCBN tools. For machining over the objects that which have the greater HRC, which are having a high hardness content of materials. And you need to have a particular definite shapes as per the design criteria. Almost all in a flat surface finishings, or else any of the counter positions, circular positions, or any different non-linear shapes can be monitored by this milling machinery with high precision. Generally, what is meant by a milling machine, and for what purpose will we utilizing this milling machine? What are the cutting parameters that are being maintained in order to get the exact finishingness or finishes in the case of this milling machine? We'll be having a detailed chart out here. Coming to this basic definition, milling machine is nothing but it is a metal cutting operation that in which the excess metal will be getting removed from the workpiece in the form of a mini chips upon monitoring with respect to the cutting tool over the work part. Nominally, this milling machine plays a major role for removing the material or the straightforward cutting with respect to a particular depth of cut, and even in the circular polation or interpolation strategy of this tool work, which is having a circulatory motions, that this cutter will rotate over the work part for removing the material, indeed to get the definite shapes over that particular entire material as per the design specifications or else design dimensional accuracies. Nominally, this milling cutter rotates at a greater speeds and even remove the metal also at very fast rate by its multiple cutting edges. Here we are having one more facility rather than the lathe machine process. There was a drilling machine, there was a slaughter, cutter, there was slaughter, planar machinery, reaming machinery, etc. That one or more number of cutters can be mounted simultaneously over this milling machine. There's a greater advantage, and hence number of working process simultaneously can be progressed over the single machinery with respect to the multiple tools that works over the work part. Even in the similar work part, we can monitor with respect to different kinds of designs with the different tools simultaneously with respect to its operational strategy, or with respect to an two or three work parts, and utilizing different tools in order to work over the work part for getting the different shapes, and even that shapes upon machining may leads towards the flat surface finishings, contoured surfaces which doesn't have any of the particular dimensional strategies, either in its horizontal or vertical phenomena, and even external and internal threadings also can be progressed over it. Likewise, the number of working processes can be commenced in the case of a single machinery. In this milling machine, the working progress will be getting done as that workpiece will be moves against the cutting edges of the milling cutter, which is fixed statistically, and the MRR process will be getting done. Nothing but metal will be getting removed as per the designed conspiracy or designed specifications in the form of a chips. The less hard materials are being utilized, such as wood materials, and a very micro range of chips, even in the case condition of this amorphous status, that will be assying to or commencing to. But all the harder materials are being utilized, such as cast iron, mild steel, etc. Automatically, HSS tool or diamond shaped tools, PCB and tools, PCD tools plays a major role in order to machine over the objects for uh, getting a particular shapes of the material, even in the flat surface finishings or diagonal edges, parallel edges, or any of the counter positions at different places of the object. As this tool or cutter, normally we used to say, is a static position which used to have a circulatory position with respect to the fixed axis, and the work or workpiece is being kept in an ideal mood within the vice, which is monitored with respect to a rotating table that is holding with respect to an uh, 3-jar chuck, and it is used to move randomly with the help of this hand screws in to and fro motions and even left and right side of directions by the handrails. Nominally, the tool will be in a fixed strategy, hence the feed rate will be confided to it as per its speed is maintained for depth of cut to be considered or the work part for commencing the material removal rate condition. And nominally, this milling machine is a widely utilized technology utilized in number of industries because of its flexibility in operation. Normally, we can say that easy way of operating conditions, and within the less span of time enter the task will be getting progressed. That too with an higher production rate and with greater accuracy when compared to the other machining processes. Even in the previous classes, we have been discussed related to this shaper machine and slaughter machine. So for getting a particular surface finishing with greater accuracy, and slaughters used to have a halo structures over the materials up to a particular depth considerations, or else over the surface finishings to a particular shapes as like of dovetail, rectangular, square, triangular representations, V-shaped cut, U-shaped cut, wedge-shaped cuts, etc. That too with a good rate of accuracy. This milling machine plays a major role in order to compete with respect to the shapers and slotting machines, and commencing those activities also with respect to the tool position change over this milling machine itself. Hence, milling machine having the capability of getting worked out over the surface finishing of the object, getting even the drilling format for getting the shape and for transforming of the material in its three-dimensional status to a particular range of dimensions achievement. Slaughters, internal threading, external threading, and particular designs related to contouring natures. Contouring natures in the sense the irregular shapes also can be progressed or any kind of the materials that is limiting in order to fix within the chunk and monitoring over the work part by the tools. These are the pictorial representations that the object commences the work or the workpiece by the tool simultaneously in almost all the three different directions or the four different directions. The first one is an cube shape, next the dove shape, and this is the dove shape, second one, and this is the tail shape which used to slide over it for getting the sliding action. This is the V-shaped notch, and this is the enlarging V-shaped of notch, and this is the stepwise cutting which is making a deep innering in nature of the step. And not only this, the T joints, U shape, double E, double V, and this is the square type of representation, the rectangular type of representation, etc. can be progressed in the case of this working process. These are the different types of working methodologies related examples. Coming to the process of this milling machine, methods of this milling machine, in what way the machining process will be getting considered, and what are the different kinds of methods that are existing for commencing the methods in the real-time basis of work. Nominally, we are having two basic methods of milling process. First one is the up milling, or nominally we will be saying this as an conventional milling process. Second one is the down milling process or the climb milling process. Then the initial one, that is up milling or conventional milling process. In this, the metal is removed by the cutter, that which is rotating for the direction of travel of the workpiece. Nominally, it should have a strong holding of the job in the jigs and fixtures. And in this type of operating phenomena, we used to get the chip thickness with extreme less in range. That too at an initial state of working process or cutting process. And at the ending section, we used to get a maximum range of working progress regarding this milling methods. As in the starting stage, it will be having a greater conditional strategy, that removing of a material or metal in the form of a miniature kind of chips, and later on the chip size will be getting increased during the working process has been commenced. Coming to the one of the limitation, that is the tendency of lifting this work from the fixtures relates to the poor surface finishing in the working process. There is a greater disadvantage that we could observe in the case of this milling method. See, this is the conventional milling method where the cutter tool is rotating in a particular direction, that is clockwise direction, and this is the keyhole that represents the origin position of the cutter, and the rotation of this particular slot and reaching the same position will leads to a confining of one rotation. So the RPM will be getting varied by the motor and its resistance capability and removing of the material upon feeding the work part. Here, in the case of this conventional milling machine, the rotating of this hacksaw is in a fixed strategy, but work part will be having moved from left to right in nature with respect to the varying the work table adjustment, that is to and fro motions with respect to the handle technology that operating with respect to a skillful worker, we could say nominally. Coming to the second method in the case of this classification, that down milling process or climbing process. In this, the metal is removed by the cutter that is used to rotate the same direction of the travel of this workpiece also. This is the climbing method. Nothing but workpiece. In the previous diagram, conventional mode, the workpiece is rotating in opposite direction or else in the clockwise direction, and towards the rotation and towards the opposite side of the rotation of this wheel, the work part is being entering. Particularly in this climb method, second method or downstream method we will be calling. And even there is a climb method. In this, upon rotation of this tool is very much similar with respect to both the conditions. But in the same rotational strategy, only the work part is also being driven for MRR process. So the teeth cut downwards instead of the upwards. See here in the before conditions is an upward removal of the chip formation during the cutting process is being considered. In the downstream process, see the cutting of this particular uh, chip elevation will be considering in the downward stream. That's the basic phenomena. In the cutting process, the direction here the tool is fixed and the circulation of a hacksaw or saw or cutter is in fixed status of rotation within the machinery equipment. But only one change it is the work part loading. In the first strategy is upstream stating the chips which are being removed upon the quotient of friction developed between this cutter and the work part and hence leads to MRR process. That MRR material removal rate will be material will be getting elevated towards the upward stream. Nothing but chip will after removing from the parental material, the chip will be getting moved with an upstream strategy. And in the climb directions, this acts towards the downward direction because in the upstream strategy, indeed to commence so the work part should be moved from left to right. Nominally, you could say that opposite to the orientation of this cutter tool or cutter teeth of the tool. And in the case of this second one, the mode of travel of the work part will be in the similar direction with respect to the clockwise rotation of the tool. It leads to the downstream of MRR process. And here also there will be an maximum. It is quite opposite to the upstream. In the upstream, chip thickness is minimum initially and maximum at the end. But here, in the case of the second technology, that is downstreaming process, initially the maximum thickness of the chip will be getting elevated, and later on upon proceeding, it will be getting decreasing in its depth or depth of cut will be getting very much decreased. So why? Because it is happening. And later on upon the end conditions, how the depth of this chip is getting decreased. Why? Because will be having the less frictional force involvement here. But another one advantage with respect to this upmilling process is that better surface finishing is achieved and less power consumption during the working progress is being considered in the case of this drilling machinery, sorry, downstream of milling machinery. So what are the basic differences? The cutter orientation is fixed. Cutter rotation is considering only in the clockwise direction. It is fixed for both the upstream and the downstream. But only the main difference in the working progress between this upstream and downstream is that the work part used to move in an opposite direction to the cutting edge of the tooth. It relates to elevation of minimum chips to initially when cutter got in contact with respect to the work part. Initially it generates a minimum thickness of this chip during the MRR process, cutting process, and later on upon increasing it will be get decreased in the case of upstream, and it is quite opposite with respect to the downstream. But in the case of this downstream, the object or work part which is need to be machine also will move with respect to the coincidence of this cutter tool, which is rotating clockwise, and upon position of a friction it will be elevating a large thickness of material over the work part, and upon that to at an initial state, and later on it will be decreasing in its thickness, having less friction involved, better surface finishing will be achieved, less power consumption in the case of this milling machine. So what is the basic principle? See here, conventional milling and climb milling, the basic difference. That is nothing but opposite. Work part is driving opposite to the rotation of the tooth of this cutter, and here in same direction of traverse of this cutter, work part is moving. Coming to the types of milling machineries, we are having different types of milling machineries. That generally milling machines, upon its operational parameters, they have been classified into several forms, but as per its size requirements with respect to the work part and based upon its design criterias, which are having a major role indeed to transform the material to a particular shapes and designs, it has been classified into many types. The first one is a column and a knee type of milling machines, planar milling machines, fixed bed type milling machine, special types of milling machines. So here the column type and the knee type of milling machines are classified based upon the design parameters or based upon the distinctive types of these milling machines. And planar milling machine commencing only the surface finishings at almost all the edges simultaneously with respect to the multiple cutter factors. Fixed bed type of milling machines. The fixed bed type of milling machine in the sense it's a standard fixing and will be work part will be fixed in the jigs and fixtures, and it may to rotate as we have been discussed in the conventional mode of working process. And even some of the special types of milling machines are also utilized. That is nothing but within the less time, more number of work parts will be getting machined, and multi-point cutting tools are being required or utilized for getting working simultaneously in almost all the sites similarly or simultaneously over the work part. It decreases the time factors or lead time factors and increases its productivity in the case of its quantity oriented, particularly in the case of its quantity oriented. That's what we are saying, that based upon the design parameters or as dimensional accuracies need to be obtained, or some of the distinctive types of milling machines. These are classified into four major groups. There is column and knee type of milling machines, planar milling machines, fixed bed type of milling machines, and special types of milling machines. So these types of these milling machines will be discussing very much detailedly in the next class.